Welcome to the presentation of Sniffer, Multimodal Large Language Model for Explainable Out-of-Context Misinformation Detection. Firstly, I'd like to give a brief overview of our work. We focus on a specific type of misinformation, known as out-of-context misinformation, which is created by repurposing authentic images with false text. For example, in this case, the caption claims Jeffrey E. Thompson pleaded guilty to funding a shadow campaign to help Vincent C. Gray win the 2010 mayoral election, and it attaches an image. However, this image is actually from another news where Harry Thomas is sentenced to more than 3 years in prison. So this multimodal claim is an example of OOC misinformation. Because OOC misinformation uses images from real news, it is easy to create and highly misleading. Existing works model this task as a binary classification, but simply providing a judgment is not enough to persuade users. Therefore, we propose a new research perspective, explainable out-of-context misinformation detection. It means providing judgment and explanation simultaneously. Here is an example output from our OOC detector, Sniffer. For this case, Sniffer provides a judgment followed by reasons. From the perspective of internal checking, Sniffer says the person in caption does not match the person in the image. From the perspective of external checking, Sniffer states the image retrieved web pages are not relevant to the given caption. Next, I will introduce how we achieve explainable OOC detection. Initially, we assumed existing multimodal LLMs could detect factual inconsistencies in image-text pairs and to generate natural language-based explanations. However, we found that they perform poorly in the OOC detection task. For example, InstructBlip 13 billion achieved only 47.4% accuracy with a 4.6% recall for fake classes on our experimental dataset. This may be due to the assumption of text-image consistency in their training corpus. Therefore, we need to design a task-specific multimodal large language model. Specifically, we employ a two-stage instruction tuning based on the InstructBlip, transforming the general-purpose MLLM to news domain and OOC detection task sequentially. For the task-specific tuning, we use the inconsistency between Caption 1 and Caption 2 to replace the inconsistency between Caption 1 and Image 2, generating supervision data with judgment and explanation simultaneously. The second challenge is that we cannot distinguish the out-of-context using solely through text-image content consistency because the original news event may not be discernible from the image itself. For example, these two images show similar content but derive from different events. Therefore, we need to capture the image's original context. We propose a three-part reasoning framework. In the first internal checking part, denoted in the blue line, we input the text, the image, and the visual entities detected in the image, asking the LLM to judge the text-image content consistency. In the second external checking part, denoted in the orange line, we retrieve the image on the web to obtain its original news context as evidence, then input them with the text, asking the LLM to judge whether the given news text is supported by the retrieved evidence. In the final composed reasoning part, we input the answers from the two perspectives into the LLM again, and ask it to combine them and obtain the final answer. Now let's see the performance of our Sniffer model. Firstly, we compare Sniffer with SOTA methods and GPT-4v, illustrating Sniffer's superiority in detection. Then, we analyze the explanation accuracy on different metrics, proving that Sniffer can generate precise explanation and different components all contribute. Finally, we conduct a human study to analyze the persuasiveness of Sniffer's explanation. Specifically, we record users' response before and after reading Sniffer's explanation. For data points initially classified as real, denoted in red, 87% changed their judgment from real to fake. For data points initially classified as fake, denoted in blue, 42% improved their confidence. This demonstrates that Sniffer's explanations effectively help debunk misinformation. Okay. That's all for our Sniffer work. Thanks for your attention.